Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss nomenclature of alcohol and phenol. Last class I have started new chapter alcohol, phenols and ethers, and I have given introduction about alcohol, phenol and ethers. Now I will continue. Today I am going to discuss nomenclature of alcohols and phenols. First I will discuss alcohols. The common name of an alcohol is derived from the common name of the alkyl group and adding the word alcohol to it. For example, methyl alcohol means CH3OH. Methyl alcohol. This actually methyl alcohol. This came from the word methane. From the methane, one H gone and OH joined, attached. It became CH3OH. Then alkyl methane, we are telling methyl. It is alkyl group, methyl. And after that OH, alcohol, we are adding. And now its nomenclature will be methyl alcohol. According to IUPAC system, already I have discussed, now it is a particular, this compound wise I am telling you. Then according to IUPAC system, the name of an alcohol is derived from the name of the alkane from which the alcohol is derived. By substituting E of alkane with suffix OL. E, letter E, a small e, alkane. Letter that you have to substitute by substituting E of the alkane with the suffix OL. The position of substituents are indicated by numerals. For this, the longest carbon chain, also called parent chain, is numbered starting at the end nearest to the hydroxyl group. The positions maybe sometimes two OH may be attached, sometimes 3. Okay, the positions of the OH group and other substituents are indicated by using numbers of carbon atom to which these are attached. For naming polyhydric alcohol, the E of the alkane is retained and the ending OL is added. This is an important point. For naming polyhydric alcohols, the E of alkane ALKANE last, then E of the alkane is retained and the ending OL is added. The number of OH groups is indicated by adding the multiplicative prefixes like di, tri, etc. that is added before OL. Di-alcohol, tri-alcohol, like that way. Alcohol we indicate as a OL, all means alcohol. The position of OH groups are indicated by appropriate locants. As for example, OH CH2 again OH is there. Suppose CH2 is there, then in the beginning OH is there and in the end carbon OH is there. then it is named as ethane. Ethane, because two CH2 is there. First carbon OH and second carbon again OH. Then its name will be ethane 1,2-diol. Ethane. You have not done anything. Fully alkane name you have written. Ethane. After that 1,2 diol, because both carbon OH is attached. Then from any one you can start numbering 1 and 2. Only 2 carbon is there. Hence the name will be ethane 1,2 diol. Okay. Now I will give some other examples, common alcohol examples plus other also I will tell you. And here this examples I will tell you, and their nomenclature is also asked in examination. What will be the nomenclature of the compounds? Okay, now I will discuss some compounds that may be asked in examination also. Nomenclature of these compounds. Now I will start with some common. Methyl alcohol. Its common name is methyl alcohol, CH3OH. Common name is methyl alcohol. And what will be the IUPAC name? Then already I told you that this from the methane word, because it is methyl alcohol. Then from the methane you add in the end E you remove and add OL. From the word alkane you remove the E and in its place add OL. Then it will be methanol. Methanol, it is a IUPAC name. Now second example I am telling you. 3 carbons are chain is there, CH3, CH2, CH2, OH. Then again it is very easy. Common name is N-propyl alcohol. N-propyl alcohol, small n, because this is the propane, hence its alkyl will be propyl alcohol. And what will be its IUPAC name? Then again from the alkane you remove one E and add OL. Then it will be propane. And actually OH is attached with carbon 1, first carbon. Okay. Then it will be propane 1-ol. The numbering will start from the carbon to which OH is attached. Then that is the first carbon. Then name will be propane 1-ol. Propane 1-ol. When you are writing 1, then you put left, means both side 1 dash you put. Don't write only propane 1-ol. 1 you are writing, then between these things propane and all 1 you have to write. And when you are writing 1, then after and before 1 you write a small dash. Now next example I am telling you, that again it is a 3 carbon, but now this time OH is attached with the middle carbon. Then now this is actually isopropyl and OH is attached in the middle. Then you can tell isopropyl alcohol. This is the common name, isopropyl alcohol. And what will be this IUPAC name? Then now it will be again propane. E you have to remove. Propane, all you have to write, but here carbon number 2 OH is there. Okay, then it will be propane 2-ol. Propane 2-ol. Now next I am telling you, now 4 carbons are there, and in the end carbon OH is attached. and 4 carbons are there total. Then now it will be automatically butyl, but it is a straight chain. You can write N-butyl, N-butyl alcohol, N-butyl alcohol. This is the common name. Then what will be IUPAC name? Then now again it is a butane, then EU remove and OHU add. It will be butane 1 all, butane 1 all. Okay. Now this next I am telling you, now again 4 carbons are there, but OH is attached to the second carbon. Then second carbon, then now you can tell secondary butyl alcohol. Why secondary? Because OH is attached to the carbon. That carbon is attached to 2 carbons, one left side and one right side. Then carbon is attached with 2 other carbon. This carbon to which OH is attached, that carbon is attached with other 2 carbon, one left side or the right side. Okay, but total is 4. Then it will be secondary. It is obviously secondary alcohol. Why? Because that carbon is attached with 2 other carbon. Then secondary butyl alcohol. You can't write only secondary alcohol. Secondary butyl, because sometimes maybe 3 carbon, sometimes maybe 4 carbon, 5 carbon. Then here 4 carbons are there. The secondary butyl alcohol. This is the common name. What is IUPAC name? Very easy. Butane, EU remove, add OL. The butane 2 all. Butane 2 all. Because at carbon number 2, alcohol is attached. Then butane 2 all. Now next I am telling you that next example. Now total carbon is 4, but it is a branch, one methyl group is attached at the middle carbon. CH3, 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 CH, and from this second carbon one CH3 is attached as a branch, correct? As a branch, then CH3, CH, CH2, OH, correct? 3 carbon is there, then last carbon CH2, OH is there, but
OTP है ITR उसको पॉज करके बाद में फिर से रिकॉर्ड कर सकते हैं. Okay.
Hello student, sorry for interruption. I was discussing about nomenclature. Then I was telling about these things. Isobutyl alcohol means CH3, CH, CH2, OH with the second carbon methyl group is attached. Then it is actually isobutyl alcohol, iso, because now with it in the middle carbon methyl alcohol is attached, and in the end CH2OH is there. Then what will be the, this is actually isobutyl alcohol. This is the common name. What is the IUPAC name? Then it will be 2-methyl branch you have to write first. 2-methyl because it is attached with carbon number 2. Then 2-methyl. After that, same way, propane, EU remove, add OL. Then 2-methyl propane. 2-methyl propane 1 all because OH is at the first carbon. Then 2-methyl propane 1-ol. Now next example I am telling you. Now with the this one CH3 branch, you can tell this propane CH3 CH3 C CH3, but in the from the middle one methyl group is attached and one OH group is attached. CH3 CH3 C CH3. From the middle carbon CH3 is attached and from that carbon OH is attached. Then here you see what is the important this OH through which OH to which carbon is attached. That carbon is actually just joined by 3-methyl group. From that carbon 3-methyl group is attached. Means OH is attached with the middle carbon, and from that carbon is attached with 3-methyl group. Then you know it is actually tertiary, because carbon to which OH is attached is joined with 3-methyl group. Then it will be tertiary butyl alcohol, because total number of carbon is 4. Then tertiary butyl alcohol. This is the common name, tertiary butyl alcohol. And what will be the IUPAC name? Then now here you see that total carbon I told you, that is the parent is 3, means propane, 3 carbon, and from the middle methyl group is attached, means carbon number 2, methyl group is attached. Then 2-methyl first you write, and after that same way propane 2-ol, 2-methyl propane 2-ol. Okay. One more I want to discuss you, that is about the this things trihydric alcohol, which is also common name is glycerol, means CH2OH CHOH CH2OH. Correct? Means you have to see the valency. Then first with first carbon OH is attached, then it CH2OH, 4 valency is over, because now it is attached with the middle carbon CHOH. That carbon is again attached with CH2OH, means first and last carbon CH2OH, and in the middle CHOH. 4 valency is completed. In the middle CH is there. Okay. And from the central carbon OH also OH is there, means all 3 carbon OH is there. Then this is actually trihydric alcohol, but its IUPAC name is not IUPAC, common name is glycerol, trihydric alcohol. And now what will be its IUPAC name? Then it is again very easy to write. 3 carbons are there, and then it will be propane. You have to remove, and OL you have to add. Then it will be propane triol. But now you have to write the position, locant. In the first, second, third, all carbon have OH group. Hence you have to write propane 1, 2, 3 triol. 1, 2, 3 triol. Okay. And then I have discussed just it was some organic compounds common name and IUPAC I have discussed. Now cyclic I am talking, cyclic alcohol. How will we do nomenclature? Then cyclic alcohols are named using the prefix cyclo and considering the OH group attached to carbon 1, attached to C1. Then here now hexane is there, hexane. Each carbon, it is a cycle, 6 carbon is there, cyclic form. And in each carbon, 2 hydrogen is there. 2 hydrogen is there, total 12. But now suppose from this is the hexane. Suppose one H is removed. Suppose from the carbon 1, from any carbon, suppose one hydrogen removed. And other group is attached like OH. Then now it is a cyclohexane. What will be the, I can say, name, IUPAC name? Then cyclohexane all, like same way. Hexane, E you have to remove, OL you have to add. Cyclohexanol. Cyclohexanol. Directly you can tell, but you just read like this: cyclohexane. E you have removed and OL you have to add. Cyclohexanol. Like that way. Now other cyclo I am telling you, that is a cyclic alcohol. Now suppose it is a 5 carbon ring, then automatically it will be just like this was a cyclohexane. Now it will be cyclopentane, because 5 carbons are there in that cycle. 5 carbons are there. Then it will be heptane. Then now same way, E you have to remove, OL you have to add. Then it will be cyclopentanol. But here in this you can say you can say ring, 1 carbon is means with 1 carbon OH is attached, and with other carbon CH3 is attached. Means 2 groups are there. One is OH, other is methyl. Then with respect to OH, next to OH CH3 is attached. Next to OH CH3 is attached. Then if OH is 1, then CH3 will be carbon number 2. Then what will be the name? 2-methyl cyclopentanol. 2-methyl cyclopentanol. Okay. Now I will discuss about phenols, nomenclature of phenols. The simplest hydroxy derivative of benzene is phenol, that you know. The simplest hydroxy derivative means that is the starting material, that is means from starting original, from the original what you will get, that is the derivative. Suppose benzene was there, from the benzene you got phenol. Then here phenol will be called derivative of benzene. Derivative of benzene is phenol. Also you can tell chlorobenzene. Again it is a derivative of benzene. Carboxylic acid, COOH group, that is also derivative of benzene. Means compound of the original. Okay, other compounds of original, correct? Then now the simplest hydroxy derivatives of benzene is phenol. It is the common name. It is its common name and also an accepted IUPAC name. This phenol actually is the common name as well as accepted IUPAC name. As a structure of phenol involves a benzene ring in its substituted compound, actually this substituted compound is called derivative, correct? Then as a structure of phenol involves a benzene ring in its substituted compound, the term ortho, meta and para are often used in the common names. Ortho means what? 1, 2 substituted. Ortho. Meta means 1, 3. With respect to 1, I am telling you. With respect to first carbon, 1, 2. That is the ortho. 1, 2 substituted. Second, 1, 3 di substituted. Di word you have to use because total 2 groups. Total 2 groups will be there. Then 1, 2 di substituted. 1, 3 di substituted means meta, and 1, 4 di substituted means para. These are actually often used in common names. Examples I am telling you. Phenol. Phenol is a original, I told you, that is the this thing's common name, phenol. And IUPAC name is also phenol. Now suppose in this phenol methyl group is attached. Then this will be called ortho position. Next to OH group is, with respect to OH, next carbon will be ortho. Then in this position methyl group is attached. Methyl group. Then its a common name is orthocresol or cresol, whatever you can tell. Then orthocresol you can tell. And what is the IUPAC name? Then very simple way, 2-methyl, carbon number 2. Now with respect to methyl group, carbon is at 2. Then 2-methyl phenol. With respect of OH, methyl is number is 2. With respect to OH, next to OH is methyl group, that is the carbon number 2, and its name will be 2-methyl. Only from this carbon methyl group is attached. Then 2-methyl phenol. This is the IUPAC name. Orthocresol is common name and IUPAC name is 2-methyl phenol. Now next example I am telling you. Now suppose at meta position, methyl group is there at meta position. Then now it will be meta-cresol. Meta-cresol is common name. Correct? Our serial number is 3rd, carbon number 3rd. Then IUPAC name will be 3-methyl phenol. 3-methyl phenol. Now one more example I am telling you, that is at para position methyl group is attached. Then obviously when it is at para position methyl group is attached, then same way it will called para-cresol or cresol. Para-cresol. And this IUPAC name will be 4-methyl phenol. 4-methyl phenol. Okay. Now I am giving some examples in which 2 OH is attached. 2 OH group is attached in benzene ring. Then it will be dihydroxy derivatives of benzene. From the benzene is the original. From that 2 OH group is attached. Then it will be dihydroxy. This is called dihydroxy derivative of benzene, and we tell it as 1,2, 1,2, 1,3 and 1,4 benzene diol. Benzene diol. Okay. Then common name of, suppose two OH is attached, and both OH is attached to adjacent, means first carbon OH, second carbon OH. Two OH is attached. Then what will be its common name? Two OH group is attached, both are adjacent carbon, nearby, next to the first carbon. Then it is called actually catechol, C-A-T-E, catechol, C-A-T-E-C-H-O-L, O-L, okay, catechol. And what will the IUPAC name? IUPAC name, that is the benzene 1,2-diol. 1,2-di, 2 ol is there, 2 alcohol. Then benzene 1,2-diol, 1,2, and before 1,2 you have to write the dash, then you have to write diol. Now suppose it is carbon number 1 and 3, position only is changing. One is at carbon number 1, other is at 3, means you can tell with respect to first OH, this is at meta position, third position. Then actually its name will be, when it is at meta position, then it will be called resorcinol. Common name you remember, resorcinol. Two OH is there, but meta position. Other is, one is with respect to first, other is at meta position. Then resorcinol. And what will be IUPAC name? Then 1 and 3 is there. Then benzene 1,3-diol. Benzene 1,3-diol. Same way, suppose at carbon number 1 and 4, OH is attached, only position is changing. It is a diol only, diphenol, you can tell, diol. Then now it will be, common name will be hydroquinone or quinol. Hydroquinone, carbon number 1 and carbon number 4, means para position is there, ortho, meta, para. Then if it is in para position, then it is called hydroquinone. Two names are there, hydroquinone, okay, hydroquinone, or other name is quinol. Both are OH, hydroquinone. Another name is quinol. And what is IUPAC name? Then again it is very easy, benzene 1,4-diol. Benzene 1,4-diol. Then this I have discussed about the phenol, nomenclature of alcohol and phenol I have discussed. Now I will discuss about the ethers. This nomenclature of ethers. Then for this also, ethers also, there will be common names of ethers, and IUPAC I will tell you. Common names of ethers are derived from the name of alkyl oblique aryl groups, written as separate words in alphabetical order, and adding the word ether at the end. Correct? Common names of ethers are derived from the name of alkyl or aryl groups, written as separate words in alphabetical order. you should remember, in alphabetical order and adding the word ether at the end. For example, now for ether, you know, oxygen will be there. O will have just like a two hand, left and right. That is actually ether group. O having two valency. Okay, one left side, other right side. It can, from this two groups can join. Both group may be same, may be different. If same means simple ether, simple or symmetrical. Symmetrical means same, you know. And if it is different, then it is mixed. It's also called mixed ether or unsymmetrical ethers. Now, here I just first example I am telling you, CH3O C2H5 means one side methyl group is attached, other side ethyl group is attached. Then both groups are different. Then this is unsymmetrical or mixed ether. Unsymmetrical or mixed ether. And name will be named alphabetically, I told you. Then methyl, M letter is there, methyl alphabetically, ethyl E. Then first you have to take the name ethyl, alphabetically it will come first, and after that M will come. Then ethyl, methyl, ether. Ethyl, methyl, ether. This is the common name. Okay, ethyl, methyl, ether. Now other example I am telling you. CH3, OCH3. CH3, OCH3. Its name will be, common name will be dimethyl ether. Dimethyl ether. And what is actually IUPAC name? Then it will be methoxy. Any one group you have to see. Here very important things. OR group is called alkoxy group. Alkoxy. 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 OR. Then here you have to understand that OR group is attached with R group. R group. You remember. Then it is becoming ROR. That is a general way. Ether formula is ROR. Then one is OR. Suppose OR is attached with R. Then R is alkyl. Don't forget. Then always OR will attach. Hence name will be, as for example, CH3OCH3. Then it is a dimethyl ether, common name. And what is the IUPAC name? Then now it become methoxy. OCH3, that is the methoxy, ethoxy, propoxy. Correct? Like that way, butanoxy. All that name, that is a group. OR is the group. Then here methoxy group means OCH3. That is attached with methane. Means methyl group. Then its name will be methoxy methane. Methoxy methane. Okay, means because this methoxy group is attached to the methyl group. Okay, I can tell methane. One hydrogen gone, and its place methoxy CH3O has attached. Hence first that group you write, and then alkane name you write at the end, always. Then methoxy methane. Now next example is C2H5 O C2H5. Both side ethyl is there, ethyl group. Then now OC2H5, that is actually this is called diethyl ether, common name. But IUPAC name, for the IUPAC name in case of ether, always OR group, just you have to consider as a separate group, OR. And now here will be ethoxy, because here OC2H5 is attached with ethyl. Hence its name will be ethoxy and ethane. ethane because C2H5 is there. Then ethoxyethane. Now next I am telling you that CH3 from that CH3 now you can this oxypropane is attached, or you can tell methoxy group is attached to propane. Okay, long chain is a having 3 carbon means CH2 CH3. Then with the CH3 methoxy group is attached. Generally a small group will be that RO group. R means will be this small in comparison to the long. Then short you can consider as a alkoxy group. Then here CH3O is attached with propane. Like that way you can understand because 3 carbons are there. Then it will be methoxy. One methoxy because this CH3CO is attached with the first carbon of propane. Hence its name will be 1-methoxy. Then now alkane name you have to write means propane. 1-methoxy propane. Now I am telling you that other example C6H5O CH3. C6H5O CH3. This is actually common name is anisole. 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 And other common name is methyl phenyl ether because one side ethyl is there, other side methyl is there. Then you have to follow alphabetical. Then here E letter is coming first, then phenyl will come, P will come later on. Then first you have to write ethyl phenyl ether. Ethyl phenyl ether, not phenyl ethyl ether. Ethyl phenyl ether. Okay, this is the common name. Other common name is this thing, ethyl phenyl ether. Actually it is other name is phenitol. Okay, ethyl phenyl ether, its another name is phenitol. And what about the IUPAC name? Then now ethoxy group is attached with phenol, benzene. Correct? Ethoxy means OCH2 CH3 means OC2H5 you can tell. OC2H5 is attached with phenyl, benzene group. Hence its name will be ethoxy benzene because OC2H5 is attached with benzene group. Then ethoxy benzene. Now next example I am telling you, that is here C6H5 with C6H5. Now another alkyl group, long chain you can tell, is attached. OCH2 whole 6 CH3. CH3 means total carbon will be 7. CH2 whole 6 means it is a heptane. Total is heptane. CH2 you have to write 6 times, and the end CH3 is there. And before and this is attached with OR, like OR, then O will be there and R will be heptyl group. Correct? With OR means O will be there, R means here CH2 whole 6 CH3 in the end, and this O will be attached with benzene benzene ring, okay, or phenyl group you can tell. Then its common name is what? Because whose name we will take first? Then it is the heptyl H heptyl phenyl ether. Common name I am telling you because O one side phenyl group is attached, benzene is phenyl, other side heptyl group is attached. Then common name will be heptyl phenyl ether. Heptyl phenyl ether, because H it will come first alphabetically, then phenyl will come. Then name will be heptyl phenyl ether, common name. What will be IUPAC name? Then here I was telling you, this is just like OR, heptyl group. Heptyl group is attached with OR. Here R means heptyl, and it is attached to the phenyl. Then its name will be 1-phenoxy heptane. 1-phenoxy heptane. Here you can take it as a that C6H5O, that you can consider as a you can say OR group. Phenyl you can consider with both, but a smaller is phenyl, and that you can consider. Okay, then it will be phenoxy. Then this is attached with first carbon of heptane. Actually, in both short is there, short group, that you have to consider as a oxy. Okay, RO group, the short you can consider. Then it is C6H5O is shorter than, you can consider both. O also you can consider CH2 whole 6 CH3, but it is long. But C6H5 is comparatively shorter. Hence, this C6H5O you can consider as a group, and that will join with heptane. Okay, or heptyl. Hence, the name will be, IUPAC name will be 1-phenoxy heptane. 1-phenoxy heptane. Correct? Both are joined. Hence, position, according to the position at carbon number 1, phenyl group, carbon number 1 phenyl group. Now that heptane is attached. 1-phenoxy heptane means phenoxy group is attached with carbon number 1 of heptane. Then it is called 1-phenoxy heptane, because phenoxy group is attached with carbon number 1 of heptane. Heptane means 7. Now next I am talking about next example. Now this CH3O is attached with CH3. Actually CH3 is attached with CH3. Then with the middle carbon actually CH3O is attached. Okay, then total actually 4 carbons are there, including CH3O, but CH3 you consider as a group. Then after that 3 carbon is there. Then with the middle carbon CH3O is attached, means RO or OR, whatever you can tell. OR is attached with, actually it will attach with always with O only. O will attach with carbon. Then here CH3O means RO is attached with middle of the propane. Like that way you can understand. Or if you straight way you can consider, then you can consider with central, with you can say with carbon number 2. With carbon number 2 methyl group is attached. You can understand like this also. With carbon number 2 methyl group is attached. Then if CH3 we are considering as a branch, then only 2 carbon will be there. 2 carbon will be there. Then if you are considering CH, this CH3O, first I will tell this common name, otherwise you will get confused. Common name only. CH3 is the one group. After that oxygen is there, and after that propyl group is attached. Very simple way. Propyl group. Correct? Then it will be what? Methyl isopropyl ether. Isopropyl ether, because this carbon number with carbon number 2 CH3 is in the branch way. It is a propane only, but CH3 is attached with carbon number 2 as branch. As you can tell, methyl, this oxygen, ether, oxygen is there, then one side methyl group is attached, another side propyl group is attached. Okay, then it will be methyl isopropyl ether. Iso, we are not telling only propyl, because methyl is as a branch. Methyl is attached as a branch. That's why methyl isopropyl ether. Methyl isopropyl ether. Okay. Then this is actually common name I told you. Methyl isopropyl ether. Now what will its IUPAC name? Then now it is very easy, that 2-methoxy carbon CH3O, you have to consider that it is attaching with long chain like a propane. Okay, then it will be 2-methoxy propane. 2-methoxy propane, because with carbon number 2 this CH3O group is attached. A smaller group will attach. Always remember, its name will come first. Then CH3O is attached with carbon number 2, hence its name will be 2-methoxy propane. 2-methoxy propane. Okay, 2-methoxy propane. Now, and also you can tell 2-methoxy propane. Then first alphabetically, first M will come first, LMNOP. M will come first, then you are writing 2-methoxy propane. But group will be, alkoxy group will be a smaller, that you remember. Then 2-methoxy propane. Now next example I am telling you, that is now again you can consider that one with oxygen, one side methyl group is attached and other side pentyl group is attached. Okay, pentyl. But here again with carbon number 3, methyl group is at branch. Methyl group is at branch. Then it is actually isopentyl. That group name, total 5 carbons are there, but carbon number 3, methyl group is attached. You can tell it is a branch form. Then one side phenyl group, other side isopentyl group. Then its name will be phenyl isopentyl ether. Phenyl isopentyl ether. Okay, and what will be the this name, common name I told you, phenyl isopentyl ether. One side phenyl group, other side isopentyl. Then phenyl isopentyl ether. Okay, and what will be the IUPAC name? Then 3-methyl butoxybenzene. Now you can see that with phenyl group 3-methyl, carbon number 3 methyl group is attached, that's why 3-methyl. Then after side, because it was 5 carbon, there were 5 carbon. Then one is at a branch. Then when you are using 3 methyl, then only 4 carbon you have to consider. Fifth one is as a branch. Then carbon number 3, CH3 is there. Then 3 methoxy, 3 methoxy, not 3 methyl, 3 methyl butoxy, 3 methyl butoxy benzene, because finally it is attached with benzene. Then 3 methyl butoxy, 3 methyl butoxy benzene, correct? Then this I have discussed about the nomenclature of ethers. Many may be there, but same rule you have to follow. Okay, means with phenyl group, this group O and long chain what I told you was attached with phenyl group. That's why name has come 3-methoxy butoxy. 3-methoxy butoxy, that is attached with benzene group. Benzene group. That's why 3-methoxy, not methoxy, 3-methyl butoxy. 3-methyl butoxy. It is attached with phenyl group. Hence the name will be 3-methyl butoxy benzene. Okay. Then it is actually, it needs practice. Hence any compound of ether you can take and just to do practice. Okay. By following the